Hello everybody, Chris here, and in this video I'm going to show you guys the basics of setting up side-scroller combat inside of a Godot project. So we can take swings at a snail enemy, deal damage to it, give it a little bit of a knockback, and we have damage text that rises above the snail. If I jump behind the snail and hit him from this side, then you'll see that the direction of the knockback also changes, and the enemy can progress to his death state. So also, you'll notice that it's not one attack, but we also have a chainable ground sword attack, so you can swing twice. And we'll be setting all of this up inside of this video. So you can get the starting point for the project down below. And if you want to download the finished project, you can also get that on the Patreon link below as well. So this is where we're at for the starting point of this tutorial, where we have air states, ground, and landing states, and we can run around. We don't have attacks yet, but the basics of the controller are working, and we also have ground we can stand on. So once again, to start from this point, there'll be a link down below where you can get the project. So the first thing we're going to want to add to our player is of course going to be the attack animations. So in an animation player for any character, you can add in new animations by clicking here and choosing new. So I'm going to call the first part of the animation attack 1, and the second part is going to be attack 2. Now, technically, these are coming from the same animation sprite sheet, but we want to separate the parts of the animation out because there may be times when the player only wants to do one part of the sword swing and doesn't want to do the follow-up attack. So in attack 1, I'm going to click on add track, and we're going to add 3 property tracks from the sprite 2D node. So the first one, when we double click on sprite 2D, is going to be texture, changing the image that is showing on the sprite 2D node. And then add track property track sprite 2D H frames, which is going to be setting the number of frames in the sprite sheet so that it is split up by each frame individually. And then let's add track sprite 2D frame so that we set exactly which of those frames we want to show at any given period of time. So now we need to keyframe texture. So right click on the graph over here and choose insert key, click on the texture file, and inside of files, I'm just going to search for attack so that we can get the attack01 sheet.png and just drag that into the value inside of the inspector. Okay, so we can kind of roughly see that this is going to be 8 frames of animation. So if I right click insert key for H frames, then we need to change the value to 8 so that it's separated into 8 individual frames. Now for frame, we can click on the sprite 2D node in the scene view and make sure you go to time 0 for our animation. And you're going to want to click on the frame keyframe button 4 times. So each time it's going to add another keyframe to the animation graph. So 1, 2, 3, 4, and that gives us our 4 frames of animation. So because we have 4 frames of animation and we want the timing to be equal on all of them, we should change the animation length over here to 0.4. Then hit enter, and you should see the gray bit at the top stop at the end of our last frame. So we can play our animation by just clicking play, and it should stop at the end because we do not have looping on. So now we can go to attack 2 and basically do the same steps, just adding in the last 4 frames instead of the first 4. So go to attack 2, add track property track sprite 2D, and let's do texture, add track property track sprite 2D H frames, and then get the frame property as well. So same process, insert a key. Now because we were just using the attack frames, it should already be there, so we don't need to change anything. Right click, insert key. Same thing for H frames. The values are already properly set up in the sprite 2D. So our keyframe is also the correct 8. And now let's go to the sprite 2D node, and we're going to increment the frame 1 so that it will show 4 here. Put the timing of the animation at 0 seconds, and then hit add keyframe for frame 4 times. 1, 2, 3, 4. I think that's correct. Let's change the time of the animation to 0.4, hit play a couple times, and just make sure that the animation is playing correctly. Okay, now we need a way to transition into these attack animations. So we can start by working on the animation tree, and then we'll put the logic into the character state machine that we set up in other videos. So in the animation tree, you can see our animations here, and one notable thing is that most of these links between the animations, the transitions, are set to advanced mode enabled. So the way this animation state machine is set up is that basically we have to call playback.travel to the node when we're in the state and we want to switch to a different animation. So we're going to do the same thing down here for the attack animations. So right click, do add animation, attack 1, right click, add animation, attack 2. Now in the top left corner of the animation tree window, use connect nodes, drag the move blend space to attack, attack 1 to attack 2, and attack 1 to move, and attack 2 to move as well. So the basic logic here is that from our free move state, which includes idle and run animations, we can switch to attack when the attack button is pressed. And then from there, we can press attack again to go to attack 2. And if we get to the end of either of these animations, attack 1 or attack 2, without having the attack button pressed down, and another state to transition into for another combo attack, then it's just going to return back to our idle run animations. But we're going to set that logic up inside of our logic state machine, which is just a series of nodes over here. Instead of setting up conditions, which you could do inside of advanced and conditions. So for each of these transitions, we're going to change the advanced mode from auto to enabled, and that goes both directions. So all 4 of these transitions, set it to enabled, and you should see the transition arrow turn gray. So now we need to manually tell this animation state machine when to switch animations. Okay, so let's add another state to our state machine. I'm going to right click on the state machine, add child node, and I'm going to type in state here. So state.gd we set up in other videos, but basically when you're in a state, you want certain logic to run for your character rather than having all of the logic crammed inside of one player.gd script file. So state.gd, we'll do that for right now. Rename this to be attack state. And then to change the script from just the standard state.gd, which is more of an abstract class if you are coming from C#, we're going to extend the script by going to inspector, script, state.gd, the dropdown, and do extend script. And then we're going to call it attack.gd. And you can see that it already inherits from state. So create. And then we'll have this blank script file that just extends from state. Okay, so if I click on this state node, you can see that can move is already an option, so we can turn that off for our player. Inside of our player.gd script, whenever we're in a state that can move is off, then our character simply can't move. So already the state does something now. We need to be able to switch to this state though, and we'll do that from our ground state. So inside of the ground state.gd, I'm going to go to where we have state input, and we're going to look for another action. But we haven't actually set up that action, so let's do that real quick. Let's go to project settings, input map, add a new action. I'm going to call it attack, and then click in the bottom right hand area where we have attack and add a new event. So the button I'm going to use for this game is just going to be the F key in order to do a first or second ground attack. So let's hit OK, close. And now we just need to do a check to see if the input is attack while we're within the ground state. And then if that's so, we jump into the attack state. So if event.isAction pressed, and then attack is the name of the action, then we're going to run the attack function. So the attack function, we obviously haven't set that up yet. So let's come down here and do function attack. And we're going to do next state equals attack state. So that variable we need to set up in a second. And then we'll also do playback.travel to the attack animation. So we'll set up the attack state and the attack animation variables right up here at the top. So at export var attack state is of type state. And that'll be something that we select in the inspector. And then we'll do at export var attack animation. And this is a name, so it's a string, and I can just default it as attack or attack 1. So having it as a exported string, you can click on the node, and then you can change the value here to whatever you need if later on you rename the name of your attack animations. So after setting the attack state, we also want to travel to the correct node on the animation tree. So playback.travel, and this is going to be attack node. So up here at the top, we'll do at export var attack state, which is a type state, and we'll set that up in the inspector. But we'll also export var attack node, and this is a type string. I'll default the name of that node to attack 1, since that's what we set up in the animation tree. So if we take a look here, we can see our node is attack 1. So by exporting these, we can customize them anytime we need, just by clicking on the ground state, going to the inspector, and looking at the assignable properties here. So attack state, I'm going to assign to the attack state inside of the character state machine. For the attack node, that's just the name of the node we're transitioning to, which is attack 1. So that should pretty much get us to the attack state for right now. Let's hit play and see if that works at all. So I'll hit F and we get one swing. We get stuck in the attack state. It doesn't return out of the attack state. If we press F again, you can see that the second attack does not play. So we need to set up some logic inside of the attack state. So the first thing I'm going to want to do with this attack state is to respond whenever the animation tree emits a animation finished signal. And we're going to check that that animation is the attack 1 animation or the attack 2 animation. And depending on the conditions within the state, we're going to return to some other state or animation. So click on animation tree. I'll go to node and let's just connect the signal right here. So the signal is emitted whenever something is finished, like animation is finished. And then we can take the data, like the string name, and do something with that within another script inside of our player object. So right click on animation finished and let's connect it to the attack state and connect. You can also do that manually inside of code if you have a reference to the animation tree directly, just FYI. So let's check here if the animation name is equal to the attack 1 name or the attack 2 name, basically anything in this attack state where we need something to do when it's finished. So we'll do attack 1 or attack 1 name, or anim name is equal to attack 2 name. So those are export variables we haven't set up yet. So at the top of our attack.gd, at export var attack 1 name, which is a string, of course, and we'll just default that to attack 1. At export var attack 2 name, which is a string, and we'll default that to attack 2. Okay, so if the animation that finished is attack 1, then we want to check if we have pressed the attack key a second time. If so, then we'll switch to attack 2. If we're in attack 2 when we finish, then we basically just want to return to our default return state. So I'm going to add an export var at the top for the return state, which is of type state. And let's actually separate this logic out here because we do different things for different states. So if anim name is attack 2, okay, then that's going to be a little different. We're just going to set the next state equals the return state. But if it's attack 1, well, we'll still do return state. If the name is attack 1, then we'll still do the return state unless we have pressed the attack key. But we don't want to check if the attack was pressed in an exact frame. We want there to be a period of time where after pressing the attack key, the game still treats the character as the player has pressed attack down. So we can set up a timer for that so that there'll be a period of time where after pressing attack that it still considers you to be attacking or trying to attack. So let's right click on the attack state, add a child node, search for timer, enter, add it. And then for the timer settings, I'm going to take the wait time and set it to something like 0.2 or 0.3 seconds, which should be half or 3/4 of the animation duration for attack 1. So this will be the buffer time where we can still be considered to be attacking even if we haven't pressed the key down. It is a one-shot, so if we go to 0, we want it to stop and time out, and then we want to remove that condition of attack being pressed. So let's set up the conditions and the state. So one of the overridable functions from the state class was function state input, which is going to receive the events of input, anything that the character state machine passes to us. So that's a input event. And then we can do stuff with that, like check if event.is action pressed attack. And if that's the case, we can start our timer. So let's get a reference to the timer so we can use it in script. So at onReady var timer is of type timer. And we're going to set that equal to $timer, which just looks in the child nodes for the node that has the same name as this timer and assigns it when the script starts. So once we have the timer, we can just call timer.start whenever the attack button is pressed. And whenever we do start, it will reset the timer. So if we already pressed attack, it'll just reset the time to 0.2 seconds. And so with the timer, we can check if it's still running by coming down here and doing if timer.is stopped. Well, then in that case, we just go to the return state. else we can use our playback variable and do travel to the attack2 node. So let's add an export variable for that up at the top at export var attack2 node, which is a string name, and that'll just be attack2. Now, if you're wondering, how do I have access to this playback variable? We can recap that a little bit. Let's jump into the character state machine, and you'll see that the character state machine has a export reference to the animation tree. And with an animation tree, at any time, you can get the parameters playback. So this is a property you can access, and I'm assigning that to each child state so that they have a reference to the state machine playback. So the state machine playback is basically what you see here. So when you have a reference to the state machine, you can tell the state machine with .travel which node you want to jump to. So if that was confusing, I hope that clears things up. So taking a look at the script, so far it seems okay, but we do need to set a return state, the variable. So in the inspector for the attack state, assign the ground state as the return state. Now let's hit play and let's test. So I'll try hitting attack once, F, and we do return to the ground state, but our animation didn't switch. So we do need to also do a .travel. If we hit F again, well, we go back to the attack state, but yeah, obviously, if we don't return the animation, that causes some problems. So when we return the state, let's also return to the right node on the animation graph. So I'll do at export var return animation node. So that'll be a string, and that is going to be move. Now, I think in my graph for the animation tree, that the M here was originally capitalized. So you got to be careful about this because it is cap sensitive. So I'm going to change move here to be MOVE lowercase move. And there's also a reference to this inside of the player script. So I'm going to jump into the player script. And if we come down here to where this is still updating one of the parameters for controlling whether it plays idle or run, this also needs to be a lowercase m. So just be careful about that whenever you change your node names in your animation tree. It is kind of sensitive. But let's jump back here. So with the return animation node, we just want to travel to that node. So playback.travel, and we'll say the name of this, return animation node. And down here, we can do the same thing. Playback.travel, return animation node. Okay, let's hit play and test again. So I'll hit F once, we get our attack animation, and we return to ground. So in that 1D blend tree of move, you can see we have run and idle animations. So let's try doing a 2-hit combo now, FF, and we get 2 stored swings. So if I do it too fast, FF, then you'll see that it doesn't actually play the second animation because I pressed it too soon. Our timer only allows the attack to count for that 0.2 seconds, not an entire 0.4 seconds like the full duration of our first attack. If you don't like that, like if this is too sensitive, then what you can just do is take the timer and just increase the wait time to something like 0.3, and that should probably be good to go. So you'll hit FF, and it'll be less sensitive. You'll still be able to get that second attack in, as long as you press the second attack before the 0.4 seconds are up. So that's basically setting up the graphics for the attack. I want to do a couple quick changes to our player. So in 2D mode, let's take a look at the player, the Sprite 2D specifically. And I actually want to re-enable centering. So I had this disabled in the original videos because it kind of makes the landing look a little off, where the feet would actually be below where the character normally stands. But I think that that might have actually been intentional for this character. But either way, when you have centering off, it actually causes more problems than it fixes for positioning your sprites between animations. So let's re-enable centering. And I'm going to take the position and just reset that to 0, 0 as well. We can take the collision shape and just make sure that the bottom of it matches where our player stands. So you can just zoom in and snap it to the exact pixel. One of the handy things about 2D Godot is that it works really easy for that. And we can test by hitting play and just make sure that our animations basically still work. So you can see the thing with the landing animation there. So if you don't like that the feet actually go below the ground for the landing animation, You could always add a offset position inside of the animation player for that specific animation and then reset the position to where the character would normally stand. And you would set that as the position for the 2D sprite, not changing it on the player or the collision shape. It's just a graphical thing, so that's why it's a 2D sprite. Next, let's actually add in the logic of our sword, which is going to require having an area 2D, where when an enemy body enters that area, we can deal damage to it. So inside of the player scene, let's right-click, add a area 2D. So just type in area 2D, it's under node 2D. And then our area 2D is going to need to have a collision shape attached to it. So we'll just keep it a simple rectangular shape. If we go to player and we take a look at our animations, you'll see that it could be argued that some kind of polygon shape might work a little better for here, but I want to keep it simple since this is just a tutorial. So let's go to the area 2D node, and I'm going to rename this to be sword. Let's right click on it, add a collision shape 2D. And with the collision shape 2D, go to the shape property in the inspector, do new rectangular shape. Okay, so this shape we want to offset it. So just drag this collision shape over here to the right and make its shape basically where you want it to be able to hit the other players during this frame of animation, or the other enemies. Could be players too, if you have a PvP game, I don't know. But something like that I think was working pretty good for me. Just like a nice, big, generous collision shape for your sword to hit. Okay, so that's the hitbox, but just having the box here doesn't actually do anything. Another thing to note is that with the area 2D, it's not actually used directly for physics, but you can respond to collisions using the signals that you would find in area 2D. So node, area 2D, stuff like body shape entered or body entered, for detecting when something enters or leaves this area. So let's add a new script to our sword node. So I'm going to click here on script, new script, and we'll do sword.gd. I guess that can be in the character folder. Okay, so we come in here. I'll get rid of this stuff. And let's actually connect that signal like I talked about. So click on node, and then click on the sword 2D, area 2D. Choose body entered body node 2D, double click on that, and connect that to the sword script. So basically the node connecting to itself, but the script attached to that node. Connect. And then when a body enters, we can check if it is a damageable character or other object. And then if it is, we'll deal damage to that character. So we'll get to that bit in a minute, but let's just make sure that this is actually working. So I'll do print body.name. So whenever a body enters, we'll print out its name to the output. Let's go to the test level 2D and let's add in a fake enemy. So I'll right click and let's do add child node. So this will be a, let's just do character body 2D. Yep. And make sure it's not nested under anything like the tile map. Click on character body 2D. Let's reposition it to be on the ground here. I'll right click, attach a child node. So we're going to need a collision shape. And then we'll make this collision shape just a simple rectangular shape. So when this object enters into this area, we should get a message in the output. So let's hit play and let's kind of see the output down there below. Let's walk over to the right and then we have character body 2D, the name of the node, character body 2D, the collision or physics object inside of our game. And if we keep walking back and forth into it, then we should keep seeing that print. Note that it only prints once whenever it enters the area. It doesn't print when it leaves, and it doesn't keep printing while the character or object is inside of that area. So it'll only damage once if we use that onEntered method. So let's rename the character body 2D now, and I'm going to call it Snail because that's the enemy we're using. Let's right click on our snail and save the branch as a scene. Go into the character folder. I'll create a new folder for enemies here, and then let's create a folder for snail, and then save snail.tscn inside of there. And we can jump into the snail scene. So our snail scene, we're going to need to have a sprite to show. So let's right click on snail, add child node, sprite 2D, hit enter. And now let's look through the project and find the art we want to use for that character. So from the Legacy Fantasy Pack, it would be under mob. snail, and then we can start with the walk sprite sheet and just put that in there. So obviously this is going to have multiple frames for each animation. So let's add a animation player to this character as well. Add child node animation player. So I'll create the first animation now. Let's do new walk. And we're going to add tracks just like we did with the player character. So property track, sprite 2D, texture, property track, sprite 2D, H frames, property track, sprite 2D, frame. And then let's keyframe the texture, which is already correct. Let's keyframe the H frames, which I believe is 8. And then let's add in the 8 frames here. So click on Sprite 2D, find the animation tab, go to frame 0 here, hit add 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. Change the duration of the animation to 0.8, toggle looping, and hit play to test out our walking animation. Okay. Now that we can see our snail, let's also change the collision shape and stretch its size to fit our snail better. Something like that. Move this down a little bit. Okay, and now on our test level, if we hit play again, it should be a little bit more clear what's happening visually when we walk into the snail and deal damage to it. So right now the snail's not colliding on the ground at the right spot. I think that's just because I put it too low. Okay, so now the snail is kind of positioned on the ground more properly. Let's jump back into the snail scene. So as I was mentioning, our snail, and really any enemy or object we have in the game that we want to deal damage to and have the option of destroying, we want to have a script attached to it, which has stuff that a damageable character would. So rather than just creating a snail script and adding a health value, what we can do instead is right-click on snail, add a child node, and we'll just do a blank node. So this will basically be a pure logic node, create. I'm going to rename this to be Damageable, and we're going to add a new script here. So new script, damageable.gd. And inside of this script, we'll add our health value. So export var health, and that can be of type, let's say float equal to 20. And then let's create a function so that we can actually deal damage to our damageable character. So let's do a function, and I'll call it hit. We'll pass in a damage value. So damage of type integer. And we'll say health minus equals damage. And then we can do something like if health is less than or equal to 0, then we can get the parent node, which is our snail object, so to speak, and queue it free, which is to remove it from the scene. So we'll do get parent dot queue free. Okay, now if we go back to our sword script, when a object enters here, we can check if it has the node damageable or a node that extends damageable, and then we can deal damage to it by calling hit. So let's go into the body here and do for child in body.get children. So this is all of the nodes that would be under snail, because snail is the physics body, character body 2D. So for each of these children, we want to check if the child is a damageable. And for that to work, we do need to give the damageable script the class name damageable. So super easy, just click on the damageable script, go to the top here and do class name damageable. Save that. Now we can go to sword, and that should clear up any errors with that. So if the child is damageable, then we want to deal damage. So we'll do child dot hit, and we'll pass in our damage value. So let's add in a variable at export var for the damage of our sword, which will be, for now at least, an integer. You can decide if you want floating point damage in your game. And I will default this to 10. Okay, so we're passing the damage of 10 to the damageable component. And then that damageable, when it takes damage, it's going to reduce the health. If the health drops below 0, then the snail or damageable character is going to die. So that should pretty much be good there. Let's get rid of this print body name and hit play and test. So I'll walk up to the snail and I'll enter. Nothing happens right now visually because it took 10 damage. Let's walk in there again. And you can see the snail is now gone. So not a lot of visual indicators right there. If you want to show some text in the console just to kind of log that, you could do something like, let's see, debug, print debug. And then we'll say body.name And then we'll say convert it to a string, the damage. So that's converting an integer to a string so that we can use it in this string. And just adding a period at the end. Okay, now if we hit play and we watch our debug log down here, we can kind of see what happens a little bit more cleanly there. Okay, so now the obvious problem is that our sword is able to deal damage to the snail, even though we're not swinging the sword. So what you can do is toggle monitoring on and off, depending on whether the sword should be able to deal damage to the snail at any given point in time. So we're going to want monitoring to be off by default. You can toggle it off here, but if you really want to be sure that it's off, then you can go into the sword script and add a ready function. So function underscore ready, and we'll do monitoring equals false, so that when we start the script, the sword is not active in all cases. Okay, next we need to add this as an animation property to our animations in the animation player. So go to animation 1 for animation player. Let's add track, do property track. Let's see, sword. Yeah, the sword area 2D, and we want monitoring as the property that we're animating. So at this frame, that's when we hit with our sword. So right click, insert key, and then we want monitoring to be on. So set that as the keyframe Boolean value. Then go here where the sword animation is done, right click, insert key, and turn it off. And that's basically it, assuming that when our animation starts that the monitoring is already off. If you want to be super sure, you could add in like another keyframe here and just make sure that it's off there. Probably unnecessary, but couldn't hurt. So let's go to animation 2 now and do the same thing. Add track, property track, sword, and go to monitoring. On 0.1 seconds in, right click, insert key, and make sure that's on. Then go to the next frame here and do right click, insert key, and turn it off. And that's basically it. So let's hit play and let's go swing at our snail. So if we run up to the snail, you can see he takes no damage while we're just walking around, but let's hit F to attack, and the snail took 10 damage. We hit F again, and the snail took 10 damage. And if we want to test that with a double strike, let's go and restart the scene and hit FF. So we hit twice for a 2-hit combo. So it probably would be helpful if we had some kind of visual text showing in the game, like floating damage text. So in our damageable script, we could emit a signal that would basically say that whenever our damageable gets hit and takes damage, we let everything else know that subscribes to that signal, so that they can respond to it, knowing how much damage was taken and which character got hit. But if we directly do it on the damageable, then that would mean that another script, like our UI, needs to directly know about our snail in order to respond to the damage it takes. So one way we can actually simplify that is by having a global autoload singleton script, which we could call signal bus. And then whenever the damageable gets damaged, we actually call the signal on the signal bus. And then our other scripts like the UI just need to look at the signal bus's signals in order to respond to all of the snails taking damage whenever they take damage. So let's create that signal bus script. So inside of the root of our project, let's create a script. So I'll right click, new script, and I'll call this signal bus. It will inherit from node, create. Let's look into the signal bus script. So we'll want to declare a signal. So the signal will be on health changed, and we can pass in any data that we need other scripts to know about. So for instance, we could do the node that was changed, which will be of type node, of course. So here you could pass in the snail node, or you could pass in the damageable node, and that would work pretty much equally well. And we can also pass in how much health actually changed. So let's make it amount changed here, which is going to be an integer. And just whenever we want this to be kind of emitted in a global sense, then we just call this from within our damageable script. Okay, so now in order to use this signal, we need to take this script and make it a global auto load. So I'll go to project settings, auto load. Let's add a script. So we're going to do signal bus GD, add, okay, and hit close. So now that that is made into a global variable, so to speak, we can go to damageable. And so whenever we get damaged, we can just emit that the health changed. But we can actually go one step further and make it so that whenever our health changes, that we actually emit that signal. And that's probably the better way to do this here, because there might be cases where our damageable character gets healed, not just hit. So let's add a enter after the export float var. Okay, so to add a getter and setter function to the health variable, let's add a colon here at the end after the default value. And then we do get colon, and the getter is just going to return the health value. And then we want a setter, which whenever you set, you're setting it to a value. So add that parameter, add the colon, and then we're going to take the health, and that's going to be equal to the new value. But before that, we want to find the difference between our old health and our new health so that we can emit that into the signal. So that's just going to be value minus health. So let's pass that into the signal. So signal bus, since this is now a global variable, we can call it just like that, dot emit signal. And the signal we are emitting, if we go to the signal bus class, is just here on health changed. So go back to Damageable, emit that signal, and then we need to pass in the parameters. So first off, which character got damaged? Well, that is going to be get parent node, which is the snail. And then the amount that changed is value minus health. So now the advantage here, once again, is that other objects don't need to know anything about this snail object. They can just look at the signal bus, connect to its signals, and then respond whenever anything's health is changed, rather than looking at each snail individually. So let's create a little UI thing to respond to our signal bus. So go to 2D. Let's go back to the test level. Let's add in a new scene here. Right click. I'll do add child node. Let's call it a UI control node. May not actually need it to be, but it won't hurt. So our control node here, we can attach UI elements under here, and then they can help organize each other. But really what we want this to do is manage the damaged text. And whenever a character takes damage, we add text above the character that took damage. So let's say health changed manager, I guess. And let's right click here and save this as a scene. Let's go to the root of our project, and I'll create a UI scene here. Health changed manager.tscn. Let's just save it. Okay, I'll jump into this scene. Let's attach a script to it. So new script, and let's create that. So what we want to do first is connect it to the signal bus script. So in order to do that, on ready, we take this and we'll do signal bus.connect. When we're connecting to the signal, so the signal name is this. So let's just copy paste the name in there. And then we need to give it the callback function that we're going to call whenever on health is changed. So we could call it something like on signal health changed. Let's create the function down here. So function on signal health changed. And we're going to receive the data from the signal. So we want to do node, and then amount changed, which is a type int. Typing the parameters is optional here, but I like to keep it very obvious what we are receiving and sending between our different scripts. So when something has its health changed, we come in here, and then we can create the text at the parent node. So this would be the snail node that just got emitted, and we can show how much health got changed in the text that we're about to create. So let's create another new scene in our project. I'll go to scene, new scene, user interface, and I'll right click here and we'll change the type to label. So when you just want to show some basic text on a line, label is a good way to do that. So let's change it to that. And we could have some demo numbers here, such as, just typing in 1,000. Of course, with a label, you can give it themes and change its font and all that good stuff, but that's going to be for another video. So we have our text here. Let's just rename this to be, let's say, health changed label. And I'm going to right click here and save branch as a scene. Okay, and then I'm going to Control S and we'll save this to the UI folder, save. Okay, now in our health changed manager, we want to have a reference to that label so we can create an instance of it. So inside of health changed manager, let's add in a export variable. So at export, and we'll say health changed label is going to be of a type packed scene. Because we have to create the instance of it, it's not really a label yet. We're instancing the scene within our other scene, and then once it's there, we can get access to all of its label functions. So Control S, save that, click on the health changed manager inside of your scene, and we would look in the inspector and be able to do stuff here. But right now it's not showing because we have errors in our project down here. So where we have on signal health changed, I'm just going to put a pass and Control S to save it, just so it'll let us kind of compile the script, I guess. And we need to assign this health changed label. So if we go into the UI folder of our project now, we can take the health changed label and drag and drop this scene, the tscn file, and put it in health changed label. And now we have a scene to instance. So we want to take this health changed label, create an instance of it. So let's do var label instance. And we could say this is of type label. Yeah, doesn't hurt. And we'll set that equal to health changed label dot instantiate. And so we're creating an instance of the scene and everything inside of it, which would include any child nodes. And then we're going to have that referenced in this little variable over here. So now we can take the node that was passed and we'll add a child node. So node.addChild, and we're going to add in the label instance. So when we add the label instance as a child of the parent node, the snail, then it's going to move along with the snail as the snail moves its position, since all of the child nodes are going to inherit the base position of its parent. Now we need to change the text of the label. So label instance dot text, and we're going to set that equal to the amount changed. Okay, of course, we have to convert that to a string because it's an integer. So just wrap amount changed with str parentheses. And if we hit play now, we can kind of go ahead and test. I'll go over to the snail. Let's hit F, and we get the -10 to appear. We hit F again, and the snail dies. The text also gets removed along with it. So that text is kind of boring right now. If we go to the health changed label, we can make it move by attaching a script to our health changed label. So let's right click on here, attach a script. We can just do health changed label.gd, create. And let's give it an export variable for the float speed, which is a vector2. And I'm going to default that to be a vector2 with no horizontal movement. But let's say for the Y, we'll do 50 as pixels per second. I believe that comes out to as the default. And then when it's processing, we'll just move the position. So we'll do position plus equals float speed times delta. And we don't need this ready function, so I'll cut that out. Let's Control S, hit play, go up to the snail, attack it, and we can see the text. Now it's going the wrong direction. That's just because we need a negative here to make it go up on the screen, not a positive number to make it go down. And if we test one more time, then it should be more or less correct. Now, the text never fades away as well, so we can have it disappear after a period of time by using a timer. So I'll right click on health changed label, add child node, timer, and let's set the time to 0.25 seconds or something. We'll make it a one shot and auto start. So with our timer node, we can just go to the node tab, connect the timeout to our script. And when the timer times out after 0.25 seconds, we just queue free on this label node. So if we hit play now and we go up to the snail and attack, the text basically goes away very quickly. A little too quickly, honestly. So I'll change the timer to maybe 0.4 seconds. Maybe we want to click on the health changed label and take its float speed and make that a little faster, like -60. Okay, and we can hit play, go up to the snail, hit attack, and that's pretty good for right now. One more thing we might want for the health changed manager is the ability to set the color of the text. So let's add two color variables at the top of our health changed manager at export var, and let's say a damage color, which is a type color, and we'll set that equal to color dot red, and then you can just pick whichever red you like here. I'll just do dark red for now. And then let's get a positive color, so a heal color of type color, and we'll set that equal to color dot green. Pick one of the greens that you like. I guess I'll do dark green, and let's save that there. So whenever we instance a copy of the label, let's set the text depending on whether the amount changed was positive or negative. So if the amount changed is greater than or equal to 0, then we'll take the label instance dot modulate, I believe is the property, and let's set that equal to the heal color. Else we'll take the label instance and set the modulate property, and we'll set that equal to the damage color. Okay, let's hit play and see if that works. So I'll come in here, let's take a swing at the snail, and we get our red text. Okay, so our snail, instead of like playing a death animation, currently just disappears from the scene. So it would be much cooler if we actually add in the death animation. So let's go to animation player, create a new animation, and we can call it dead. I'll go to the start of our animation, add a property track, same routine as before, texture, sprite 2D H-frames, and then sprite 2D frame. So right click, insert a key for the texture, and let's search for the dead sheet from Snail. So I'll drag that in there, and this looks like it has 8 frames. So I'll right click, insert key, make sure H-frames for the dead animation is also 8. And then let's keyframe all of those frames, starting at frame 0 in the inspector for the sprite 2D, and then press add 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. Go ahead, play the animation, and make sure it plays the right frames here. And I'll change the animation duration to 0.8 to reflect the fact that we have 8 frames. And let's hit play one more time. Okay, and that looks good. So to switch between our animations like walk and dead for the snail, let's create a animation tree, just like we would for the player itself. So I'm going to add a child node, and we'll call it animation tree. Inside of this animation tree, I want to assign the animation player. I want to create a new tree root, which is going to be animation node state machine. And then let's add in the 2 animations, walk and dead. So let's connect them. Connect start to walk, so it automatically plays walk, walk to dead, and just kind of position it roughly like this. So for walk to go to dead, we're doing manual advancing using .travel. So let's change this to enabled. And it's fine for start to automatically go to walk here. So now to set up the logic for when our character switches states, let's create a character state machine, which is the same thing that we have over here on our player, and then create a couple new states. So I'll right click on Snail. Let's add a child node, and this is going to be character state machine. Okay, and then I'll right click here, add child node state, and we'll just create it as a state.gd. I'll rename this to be walk. I'll right click, add child node state, and I'll rename this to be dead. So in dead, the character cannot move, and in walk, the character can move. So our character state machine, let's take the properties, assign the snail as the character, animation tree as the animation tree, and the current state will be walk. Okay, so I'm also going to add a third state in to the character state machine, which is going to be a hit state. So let's add in that state, hit, and let's extend the script as a hit state. And I'll make this kind of a generic one because this could apply to many different enemies. So I'm going to actually put this in the character folder, let's say for now. So resources character hit state.gd. Let's create an add. And I'll actually give it a class name here. So in this hit state, let's get a reference to our damageable component or our damageable node. So at export var damageable is of type damageable. Control S, and we'll assign that to the damageable. So because our state extends node, we can still do stuff like function underscore ready. And what we'll want to do is damageable.connect, and then we'll create a local signal when we have something on the snail and we want to respond to that thing on the snail, like the damageable, but only this snail is damageable. Then we can respond to that. When it gets hit, then we can enter the hit state through here. And you could do other ways too. Like you could probably just put in the damageable script that when it gets hit here, you just move to the hit state. But I want to be a little bit more consistent. So damageable.connect, we'll give it a signal name. And we haven't set this up yet. So on hit makes a lot of sense. And then we can give it a callback name. So on damageable hit. Let's create that down here. Function on damageable hit. and we'll pass that for right now. So let's go to Damageable, and we'll create a signal here as well. So signal on hit, and if we want, we can pass data to the signal. We don't have to use it, but we could still do it. So I'll just keep it consistent with the on health changed. So node of type node, and then let's say damage taken of int. So when we get hit, I want to do emit signal on hit, and we're going to pass in the get parent, and we're going to pass in the amount of damage, which is the damage we just took. Okay, so we have that signal. If we go to our hit state, then we're going to connect to that signal here, and then we can get the parameter data. So node, and then damage amount. Okay, and I'll use this callback for the signal to basically override whatever state the character state machine is in, and force it to switch to hit or force it to switch to the death state. Since basically the hit state is going to be our highest priority, kind of overriding everything for the enemy. Or at least that's how I'm going to do it for right now. So I guess we'll need a reference to the state machine itself. So character state machine here. Okay, and we can just assign that from up above. So what we'll do is we'll have kind of a interrupt function, which can override whatever the character state machine is currently doing. So we'll emit the signal from our state and have the state machine pick up on that and respond to it. So let's go to state.gd, and I'm going to actually have a signal. So let's see, what can I put that? Under the variables, signal, interrupt state, and I'll pass in a state, and let's call it new state. So when we emit this, we'll have the state machine respond to it. Let's first emit it from hit. So let's see, emit signal, and this is going to be interrupt state, and we want to give it the new state. So the hit state is going to interrupt with itself unless the character is already dead. So let's have a condition here. So let's say if damageable.health is greater than 0, then we'll emit that as the signal. Otherwise, we're going to emit signal with the dead state. So let's go up here at export var dead state is a type state. Okay, now we can assign that in the inspector. So assign the dead state, and we'll either switch to the hit state or the dead state. Okay, so when we switch to the dead state, we also want to call the playback.travel to the dead animation node. Okay, so let's add that variable at export var dead animation node of type string, and I think that was just called dead by default. Now our hit state doesn't actually have an animation. Instead, we'll add the knockback in later. So for right now, we're just switching to that state. So now in the character state machine, whenever we get access to all of our children, we also want to connect to the signals that we are emitting, the interrupt signals. So let's add a bit down here, connect to interrupt signal. So we'll do child.connect. We need the signal name, which is interrupt state. And then we're going to respond to that on state interrupt state. And that's actually not wrapped in strings. Okay, so now let's take that down here to the bottom of our state machine, function on state interrupt state. And we just have the new state, which is of type state. Now, for right now, we don't have any priorities or anything in our state machine. So we're just going to assume that if we use the interrupt, it overrides everything. So let's see, we're going to switch states to the new state. And I think that's pretty much it, actually. But one thing we do want to do is make sure that the animation tree actually plays for the snail. So we could do that on a snail script. Let's go to the snail and let's add in a new script. We'll start with the basic character body movement, create. I'm going to remove the bit about jump velocity. Let's remove the option to jump. It's not a character, so we're not using input. And then for this other stuff, let's comment it out for right now. So I'll select all, right click, toggle comment. Okay, so the only thing that the body is going to do is drop to the ground. Let's add in function ready. And let's take the animation tree. So we'll need to do an onReady for that. Up at the top, at onReady var animation tree of type animation tree. It's going to be equal to $animation tree. Okay, now that we have that, we can do animation tree.active equals true. So whenever our snail starts, the animation tree will start playing. Let's hit play and see if we can get the walk animation to play. Cool. So it is working. Let's swing at the snail. Okay, it takes damage. Theoretically, it should be in the hit state right now. Let's hit him again, and it just dies immediately. So we probably forgot to remove the Q free. Let's go to hit and... Oh, no. Sorry, Damageable. And we'll get this if health is less than 0 and remove that. Let's hit play again. Hit the snail once, twice. Okay, and then we get the death animation. So we can see that our signals are working really beautifully there. Okay, so after the dead animation is done, I want to, let's say, go into the Damageable script and remove the character from the game. So animation tree, let's go to node, do animation finish, connect that signal to Damageable. And then let's say in here, if the animation name is equal to the dead animation name, then character is finished dying, remove from the game. So we'll do get parent dot q free. So now we just need to put a variable for this up at the top, dead animation name up at the top. We'll do, let's say below the health variable, at export var dead animation name of type string is equal to dead by default. Okay, now if we click on if we click on Damageable and go to the inspector, we should see that here. And that should be all we need to do to remove it from the scene once the death animation is done. So let's hit him once, hit him a second time, and the character removes from the game. That's what we want to see. Now you may notice that the snail doesn't really move or do anything. So let's add in some super basic movement to the snail. Let's go in here and we'll just say that the snail is going to move to the left by default. So up at the top, we could have something like at export var, let's say starting move direction is going to be a vector2, and that'll be equal to vector2 dot left. So the character is just going to move to the left at the start. So let's take this direction down here, uncomment this bit, right click, toggle comment, and the direction is just going to be equal to the starting move direction. So this was originally a float, I think. So because it's a vector now, we want it to be .x. And let's make it clear that this is a vector2 as well. So we set our velocity equal to our direction x times the movement speed. So let's hit play. And we'll have a very, very fast snail moving to the left. You also see that it collides with the player because they're both physics bodies. So first thing I'm going to want to do is slow this snail way down. Let's take its speed and set it to 30. Also, I don't think that needs to be a constant. Let's do at export var movement speed, and that'll be a float, and we'll set that to 30.0 by default. Okay, now movement speed, we'll take that down here and replace the variable names. And now if you click on snail, you can set the movement speed in the inspector. Let's hit play and test that again. Okay. So this really depends on what kind of platformer you want. You could have characters that collide and stop each other, stop them from moving altogether. Another thing you could do is have them only be able to damage each other and trigger knockback states. Like when I hit F, they can take damage and go into a knockback, but not actually be a physical collision between the player and the enemy. And that's kind of the way I think I prefer the scene to be right now. So let's quickly set that up. So let's take the snail, the character body 2D, go to the collision tab, and we'll change its layer from 1 to 3. It's still going to look at layer 1. Layer 1 will be our world layer. Layer 2 will be our player layer, and layer 3 will be our enemy layer. So if we want to hit an enemy, then we would want to use mask 3 on the sword, which we'll do later. Let's click over here and edit our layer names. So layer name is going to be world, layer 2 player, layer 3 enemy. And that'll help us separate out the physics between different objects in our game. So hit close there. So let's go to player. I apparently have 2 collision shapes. Let's remove one of them. There should only be one. Click on player collision, change its layer to 2. While we're at it, let's just take the sword and take its collision to look at 3. So we do the mask for 3. Now the sword can only hit enemies. It can't hit players. And you might also have another layer for NPCs. So one way of differentiating between which character is which. Also, the sword shouldn't really exist as its own physics layer. It's more of just a detection zone. So I'm going to toggle off layer 1 there. Okay, now let's hit play and test how the physics work right now. So the player and the the player and the snail can walk right by each other, but the snail should still be able to be affected by gravity. So bye, snail. Oh, and of course, if I swing at the snail, because the sword's looking at layer 3, the snail's still going to take damage and die. But one thing you may notice is that the snail doesn't stop moving when it moves to the hit or the dead state. So let's change the snail's logic a bit. First off, with dead and hit, then can move should be set to false. And let's jump into the snail's logic. So by default, the snail doesn't know anything about the character state machine. So let's make sure that it does know about that and can react to it. So let's do a @onReady var state machine is of type character state machine. And we're going to do equals $ character state machine. So as an extra condition for the direction, we want to check if the state machine dot check if can move. Okay. And so that'll mean that the state has to be able to move for the character to keep trying to move. So let's hit the character and you see it stops moving, hit again, and it doesn't continue moving. So that's good. So lastly, for our character, we kind of want to add in a knockback movement for our hit state. So we could add that into the physics process, or we might want to start like migrating our code a little bit more to our state machine rather than the character body 2D script. So on our state machine, when we enter the hit script, we could just take our character with function on enter, which the state machine will call for each state when it's switching to it. And we'll do character dot velocity, and we'll set that to our knockback velocity. So our knockback velocity, let's set that up here at export var knockback velocity. And that can be a vector2, and we'll set that equal to vector2 dot, let's say 100 and 0 for right now. Okay, if we click on hit, we can see our knockback velocity defaults set up there. Now, this is going to conflict with the snail's logic for right now. So what we could just do is make sure that the state machine is not in the hit state. So in our snail script, we could do that pretty easily by doing something like @export var hit state of type state. And then we'll just check with else if the state machine dot current state does not equal the hit state. And then we just need to set in the inspector the hit state, which we'll do right there. And now this won't execute while this bit over here is trying to. So later you might want to just move this kind of movement stuff into the walk or dead hit state scripts and just control the movement there. But for right now, this is good enough. So we'll hit play. And let's come in here. Let's hit him once and we get our knockback. If we hit him again, then he switches to the dead state and is not moving, but is also not using that velocity that you had here. And we could also say on exit, maybe we just want to take the velocity and set that to none. Yeah, I think that wouldn't hurt. On exit, we'll do character.velocity, and we'll set that to vector2.0. Just as an extra precaution, and make sure that nothing weird happens with the speed when we're returning to other states. Okay, so we kind of have a knockback now, but it's really clear that it's not returning to the normal state when we enter the hit state. So we need to also add a timer to our hit state. How long should it be stuck in that state before we return to the walk state? In our hit script, let's add in @export var return state of type state. And let's add a timer by right-clicking on hit, add child node, timer. Okay, and then we can just connect the timeout to the hit script. And then we'll say next state equals return state. Okay, now we need to start the timer on enter, timer.start, but of course we haven't accessed the timer. So let's do @onReady var timer is equal to $timer. So we'll start the timer. Let's click on timer, inspector, make sure it's a one shot, and we'll make the wait time 0.25 seconds. So that's how long the character will be stuck in his idle state. Let's hit play and kind of test that. I'll swing at him, and it's still not returning. Interesting. So let's go to this timer timeout. I'll set a breakpoint there, hit play, and let's see if that actually occurs. So play, it does, but I just remembered in the hit, we forgot to assign the return state. So return state is walk. Okay, and I'll refresh that to be the dad animation name. Okay, remove the breakpoint. Let's hit play. Let's test this out. I'll hit him, and he goes back to walking. Okay, that's more what we want to see from our character. Okay, the last thing is our knockback is not directional specific. Right now, the knockback is always to the right because we're not hitting the snail from the back. So we want to get the direction that we actually hit the snail from so that we know whether he should be knocked back to the left or to the right. So let's go to the player and enter the sword script, and let's get the direction between the body and the sword node. So we want to get the direction from the sword to the body. So let's do a variable direction to damageable. It's going to be equal to, let's see, the body.global position minus the global position of this character, or we could even do get parent. That might be a little better because then we're getting the position of the player. So get parent dot global position, and then I want to know basically, is it a positive direction to the right or is it a negative direction to the left? So let's get the sign of that. So direction sign is going to be equal to the sign of direction to damageable. Now that should be a vector, so really we only care about the X here since we're doing left to right knockback. So we have the direction sign. Now let's figure out what direction we want the knockback to be in. So there's three possible cases here. One is that the direction sign is above 0. Really, it would just come out to +1. And if that's the case, we want to do child.hit with damage, and we want to give it the direction of, let's see, vector2 dot right. And then we have an else if the direction sign is less than 0, then we're going to hit the character to the left. So child.hit damage vector2 dot left. Otherwise, in the case that the character is literally right on top of the player, I guess a knockback doesn't make sense. So we could just do no knockback with child.hit damage and then vector2.0. Okay, now for this to actually work, we need to add that extra parameter to the hit function on the damageable. So we can get rid of these messages now. Let's go to the damageable script, go down to hit. Let's add in the direction here. So knockback direction. So vector2. And we'll want to pass that into the on hit knockback direction so that we can use that within our hit state. So we know what direction the knockback is occurring in. So let's add that as a signal parameter, knockback direction vector2. Okay, now we jump into the snail hit. So we get the on damageable hit. We want to add in that third parameter, knockback direction vector2. And let's actually take the character velocity bit over here. Remove it from on enter. We'll still have the timer start on enter. But let's set the velocity when we interrupt. So we'll do it like this. Character velocity equals knockback velocity times knockback direction. Okay, yeah, I think that makes sense. So last thing, we might want to just take the knockback velocity and call it knockback speed. Make it a float. Since the knockback direction kind of already has the direction, so we just need the magnitude, so to speak. So knockback speed 100.0, and then we'll go down here, knockback speed times knockback direction. Yep. Okay. Let's hit play now and see if all that works. So we'll hit him. Okay. He gets hit. Obviously, this time he's just going to die. Oh, yeah, there's another thing. We need to make sure that the sword flips positions when we switch directions as well. We want to have a left position and a right position for our collision shape. So I'll add a script to our collision shape, new script, and I'll call this facing collision shape 2d.gd. Create. Let's add in two export variables at export var left position, or let's say facing left position, which is a vector 2, and then at export var facing right position, also a vector 2. So that'll be it for the script. Now in the 2D view, we want to set the values for the position where the sword should be swinging when the character is facing to the right and facing to the left. So it's basically going to be a negative value for the left position. Let's see what values we have for the collision shape right here. Let's say a position of 30 and the Y of 0. And then let's stretch the collision shape a little bit more, kind of like that. Okay, now I'll take the position 29. And let's take those values and put them up here. So facing right position of 29, and then negative 29 for the facing left position. Okay, now that we have that, let's create a signal on our player where whenever our player flips direction, our sword can also flip the position of this collision shape. So in player, let's go up to the top. I'll create a signal. So the signal will be facing direction changed, and we'll say facing right is the Boolean parameter, since our character can only face left and right. So when we come down here, we're going to emit that signal. Emit signal, and let's say facing direction changed, and we're going to do sprite.flip h as the thing that we're passing. Okay, also that should be wrapped in quotes, the facing direction changed. So hold on, up at the top, facing right as the Boolean. So that should be true. So if we flip, we're actually facing the left. So this is going to be the opposite of that. And we can emit that down here below this if else check. So we emit the signal. We say if it's facing the right, which is the opposite of if flip H is checked or not. And then we can respond to that from our sword script. So let's go into the sword script and we'll get a reference to our player, I guess. So at export var player of type player. And if I remember right, player doesn't have a class name yet. So let's just add that in. Class name player. Okay, now in the sword script, we can easily grab it. So we have our player on ready. We just want to connect to that signal. So player.connect, and it was facing direction changed. And then we'll say for the callable on player facing direction changed. Then we'll have that. Okay, and now this script also needs to reference the collision shape. So let's do at export var facing collision shape 2D. I guess we'll have that. So facing collision shape. And I think I haven't written a class name for that as well. So in the collision shape 2D, let's do class name facing collision shape 2D. Copy that, go to sword, paste that in there. Okay, now we need to create this function on player facing direction changed at the bottom. So function control V, because these are signal callbacks and not meant to be called directly, I believe that it's the right practice to give it the underscore here, like on body entered was here. So for this signal, we get the Boolean facing right, and we just use that and we decide whether the collision shape is going to be on its left position or its right position. So facing collision shape 2D, you know what? I'm just going to rename this to be facing shape. Okay, it's a little bit less intensive to type. So let's do facing shape dot position is going to be equal to the facing shape dot right position. And that's if facing right is true. So if facing right, then we put it there. Otherwise, we'll do facing shape dot position equals facing shape dot facing left position. Okay, let's see. I think that is it. Okay. So in order to see that our sword position is flipping, let's go to debug and do visible collision shapes so that we can see that in game. Hit play. And now let's try moving the player. Oh, hold on. Player.connect, facing direction changed. I might have had the wrong signal name. Let's go into player. Signal, facing direction changed, facing right. Oh, okay. So that's because we didn't assign the player. So on sword, assign the player, and then assign the facing shape. Okay. Now let's try that again. Hit play. We go in here, and now you can see that the sword's hitbox flips along with our player. So let's hit the snail from behind. Okay, and he's off the cliff. Okay, so let's let's duplicate the snail a few times. I'm going to go to our test level scene, click on snail, Control D, move him over to the left, Control D, move him over to the right. Both times it's the right, actually. Hit play, and we should be able to see all of our snails acting correctly. Let's beat them up. So 1, 2, that one's down. Let's jump behind, hit them. Okay, we can see that the knockback is actually occurring from the right direction. And also our hitbox for the sword is facing the left. So our combat for the player is now working correctly. So there's one last tiny tweak I want to make before we wrap up the video. I know I've said that like 5 times now. But in our test scene, if I move the player close to the ground before the scene starts, which would be pretty natural, and you may have noticed this if you did the same thing, and we hit play, it's that the character will actually switch to the air state and then the landing right when the scene starts. So to prevent that from happening, we can just use a tiny little timer in our ground state where this condition for switching to the air state can't occur until at least 1 frame of the game has occurred, so that the character body can check if the character's on the ground so that it will properly stay on the ground. So right click on ground, add a child node, timer, and then for this timer, I'm going to do the wait time 0.05 seconds, 1 shot, and auto start. Now in our ground state, let's just get access to that timer. Let's do @onReady var buffer timer is of type timer, and that's going to be equal to $timer. Or we could just do $buffer timer and then rename the timer as well. Just make sure the names match. That's all that matters there. And we'll check here and buffer timer dot is stopped. So if the buffer timer is stopped after 0.05 seconds, then we can switch to the air state. So what that'll mean is that when we hit play now, the character will start on the ground. It has time to actually check if the character was properly on the ground. And aside from that, that's really it for this tutorial. We've got some basic combat dealing damage to the enemies. If you wanted to make the player take damage, you would just do the same thing in reverse, add an attack zone for the snail hitbox, give a damageable component script to the player, and just make the player have a hit state, a death state, that kind of thing as well. It's just repeating the same steps for a different character. So I hope without going too long that is a pretty good crash course on how to do attacks and enemies inside of Godot engine for a side-scrolling platformer once again. So once again, if you need to access the finished project, you can find a link to it in my description to my Patreon account, where I have the full project exactly how you see here. Totally ready for you to use, and feel free to use any of these scripts in your own games. So thanks for watching to the end. I've been Chris, and hopefully I'll see you guys in some of my future game development tutorials.